solving linear equations. Every linear equation, and I do this a little different, okay? And it's not going to be the same way that you were probably exposed to it in Algebra 1, but here's my advice for you. If you already know how to do this, and it makes sense to you, do it the way you want to do it. It's not going to hurt my feelings if you don't do it my way, okay? But all equations, all linear equations, to me, can be solved with 3 steps. Step number 1, and if you don't know this, you can write it down. Step number 1, you always get rid of parentheses. If you have a set of parentheses, and let's talk about how you do get rid of parentheses, see if anybody remembers. Let's say you've got a 2 outside of x plus 3. You've got a 2 in front of parentheses and x plus 3 inside of parentheses. Does anybody remember the property, the name of the property that we can use to remove those parentheses? Or do you remember how to remove them? How do you multiply 2 times x plus 3? What do you get when you multiply those 2 things together? What are you left with? 2 times x is, and 2 times 3 is. Pretty much, I took the 2 and I multiplied by everything. 2 times x plus 3 is 2x plus 6. Now, does anybody remember the property's name? Starts with a D. What is it? Distributive property. The distributive property says if you've got a number in front of parentheses, or it doesn't have to be a number, it could be a negative. If you have a number, which I say it could be a negative, that's still a number. Does anybody see that number? What number's standing right there? It's turned sideways. It's so skinny you can't see it. That's a 1. Anytime you have a negative in front, it's understood to be a negative 1. The way that you remove that, same distributive property, negative times x is negative x, negative times 3 is negative 3. That's also the distributive property. But it says if you have a number or negative in front of parentheses, you multiply that number by everything inside parentheses, distributive property. So step number 1, remove parentheses. Step number 2, combine any like terms that you have. What I mean by like terms, 2x, 3x. You can put those together. 5y, negative 7y. Oop, that's an x. Negative 7y. You can put those together. 5x, 2. Not like terms. Anytime you have like terms, those can be combined. That would be step number 2. And then step number 3, multiply and divide, and we'll get to that in just a second. All equations can be solved with those 3 basic steps. Let's solve some. Actually, let's start with the tough ones. Let's skip over here. Let's try this one to begin with. Step number 1, always remove parentheses first. There are none. Check. Yeah. Step number 2. And like I said, this is different from the way that you were exposed to it last year. You pick which way you like best. You pick which way makes sense to you the most. You do it that way. Step number 2 says combine like terms. Destiny, 3K. Does it have any like terms? Anywhere up there? There's 4 terms, by the way. 3K is a term, negative 1 is a term, negative 12 is a term, negative 8K is a term. Destiny, 3K. Does it have a like term? Does everybody see that? There's a negative 8K over here. Those are like terms. Both of them have K's. And then negative 1 and negative 12, those are like terms. They don't have any letters. So if they have the same letters, they're like terms. Or if they have no letters, they're like terms. Now watch how I combine this. The rule is, and like I said, and this is different, I know. The rule is, if you have a term, which in this case you have 4, and you want to move that term from one side of the equal sign to the other side of the equal sign, you can do it. The way that you did it last year is if you had a minus 8K over here, you could do plus 8K as long as you did it to both sides, right? Y'all remember that? Well, I do it different. Here's the way that I think of it. I want to put all my like terms together. I've got K's on the right side. I've got K's on the left side. Let's put them all on the same side. The way that I move it, here's my equal sign. If I want to move my K's that are over here to put with these 3 K's here, all I do is I change my minus 8K to a plus 8K. Since I moved it, mark it out. And what I'm going to try to do, I want all my K's on one side, and anything that's not a K, put it on the other side. This is not a K. Minus 1 to move it to the other side. Remember what I told you, it's a term. Minus 1 becomes plus 1. Move it, mark it out. Move all your letters to one side. Anything that's not a letter, move to the other side. That's the rule. Combine all like terms. Jordan, I have 3 K's plus 8 K's. How many K's is that? 11 K. Good. Bring down your equal sign. And anybody, negative 12 plus 1, what is that? Good. So you see what you did. And like I said, do it the way that you want to do it. Do it the way that makes sense to you. But what we just did is we saved us some steps there, didn't we? Because last year you had to do plus 8K here, plus 8K here, and that was probably one step where you'd mark these out, you'd add these, and then in your next step you'd probably do plus 1 and plus 1. That's just, it saves some time. Saves some paper. Your last step after doing that, think about it. Every problem, every linear equation that you're going to work is going to have one variable, just an x, just an r, just a t. So you're going to move all of those to one side, and anything that's not a letter, you're going to move to the other side. So you're always going to be left with something that looks like this. Your last step will always to be either multiply or to divide. I want to get k. The whole ultimate goal is we're trying to get k by itself. So the way we did that, first we moved all the k's to one side, all the numbers to the other side. Now, let's try to get rid of this number that's attached to it somehow. Since 11 is being multiplied, you do what's called the inverse operation. Don't have to write it down, but it's the inverse operation. It means the opposite operation. To move an 11, which by the way, we did that up here too, minus 1 turned into plus 1. Plus 1 was the inverse operation. So we're doing the inverse operation here. Since this is being multiplied, in order to remove, that's 11 times k. In order to remove just this part, the 11 comes to the other side, and we're going to divide. Divide by 11. Mark it out. Now k is by itself. The whole goal is to entirely isolate k. K is now equal to a negative 11 divided by positive 11, which is negative 1. If you want to, you can always go back and check. Everywhere you have a k, let's check this. We think that k is equal to negative 1. Let me get this back down here. This is when we worked. We think k is negative 1. We think that 3 times negative 1 minus 1 will equal negative 12 minus 8 times negative 1. You can always plug it in. 3 times negative 1, let's just do it like this. It's negative 3. I'm going to put a question mark because I don't know if it's equal or not. Negative 12 and negative 8 times negative 1 is a positive 8. Is that equal? Negative 3 minus 1 is negative 4. Negative 12 plus 8 is negative 4. So yeah, that's equal. That is the only number that you can plug in for k to make that a true statement. Make it a true statement. Let's try another. Let's move on and do another one. Let me try the second one here. We'll do it together. 4c minus 10 plus 2c equals 5c minus 15 plus 12. Again, with a new set of ways, with the 3 steps that I do. Step number 1, remove parentheses, check. There are none. Step number 2, anything that is a C, move to one side. Anything that is not a C, move to the other side. Combine all like terms. Help me with that. Is it Kirsty? I've got a 4C over here. Kirsty, do you see any other C's? 2C right here, good. And anything else? Those are all your like terms. Everybody good with that? Now let's rewind for a second. Anytime you want to move a term from one side of the equal sign to the other side of the equal sign, you change its sign. 2C. Am I moving that from one side to the other side to fit it with this 4? No. So you do not change the sign. Plus 2C stays plus 2C. 5C. Notice where the equal sign is. Does move across, and it becomes minus 5C. Mark them out. I've moved all my C's to the same side. I've just stacked them up so I can add them. Anything that's not a C is moving to the other side. You can put it with either one, it doesn't matter. We'll list it under the plus 12. So plus 12, we're going to put the minus 15 with it. Notice it stayed minus 15 because it did not move across the equal sign. Minus 10 becomes plus 10. Mark it out. Brianna, add all those C's up and tell me how many I now have. 4 plus 2 minus 5. 1 C. And guys, if there's 1 C, I'm really good at counting. Okay, I can count nearly past 50. If it's 1 C, you don't have to put it there. I can count, that's 1 C. Okay? You don't have to put a 1 in front of that. If it's understood, I told you, standing right here, standing sideways, you just can't see it. Bring down the equal sign. 1 C is equal to 12 minus 15 plus 10. That can be done in any order, by the way. Addition and subtraction, as long as you keep the sign with it, you can move those around. If you want to do 12 plus 10 minus 15, if you want to do negative 15 plus 12 plus 10, it doesn't matter what order. I do 12 plus 10 and then minus 15, because then you have positives. 12 and 10 is 22 minus 15. Anybody got it? C is 7. You see why I didn't put the 1 C? Because then you're going to divide by 1 and you're going to throw a completely pointless step in there. So C is equal to 7. You can plug that in for all the C's if you want to check it, but I promise, I'm confident, C is 7. Any questions? Now let's work some that's got parentheses. That's the only other step. We'll do some with fractions and decimals here in a minute, but if we're able to do this, we're going to check. Step number 1, remove parentheses. We remove parentheses by using distributive property. I'll show you in a second another way that you can actually remove parentheses too. But for now, we remove parentheses by doing distributive property. Everything inside those parentheses on the right side is being multiplied times 7. That's 7 times all that stuff. So Nicole, what I need you to do for me is I need you to take everything inside here and multiply by 7. That's what that distributive property says. This stuff times 7. So the other stuff stays the same, 30 plus R, equals, Nicole, multiply these by 7. What do you get here? Good. So 14R and a negative, good. Any question on how to do that? Distributive property, no more parentheses. So now what do? Same stuff we did on the last one. Step number 1, remove parentheses. Step number 2, like terms. Okay, now let's talk about these like terms. I told you get all the R's on one side, get all the numbers on the other side. I did not say what side to get them on. And that's important here. If you don't like working with negatives, you better be careful what you move. If you move 14 R's to the left side, does everybody understand now that a positive 14R would become a minus 14R? And you'd have 1 minus 14. If you have $1 and I steal 14 of it, I promise you owe me money. That makes sense. 1 take away 14 is a negative. If you don't want to deal with negatives, what should you move? The positive 1R. Why not take this positive 1R and write it as minus 1R on this side? Mark it out. But if I'm going to move my R's to the right side, I told you I wanted numbers on one side and R's on the other side. Let's move our minus 35 over here to the left side and turn it into plus 35. That is completely legal as long as you put the R's on one side, you put the numbers on the other side. $30 and 35, anybody gives me. And that is equal to, notice what the equal sign is, 14 R's minus 1 R gives me 13 R's. So 65 is equal to 13 R's. Your last step is always to either multiply or divide. We got rid of parentheses. We combined all our like terms. Now we either multiply or divide. We're trying to get R by itself. Abby, R is being multiplied by 13, so any ideas on the inverse operation? How are we going to get the 13 to the other side? Good. Mark it out. Since it was being multiplied, we move it over here and divide. 65 divided by 13, anybody do that in here? 5 is equal to R. Or I would rather see that as now R equals 5. 5 equals R, R equals 5, that's the same thing. Next problem says negative 28 plus 2x equals 1 plus 3 parentheses, 5 minus 3x. First step is always to remove parentheses. We have a 3 outside parentheses. And notice, this is very important too, we have a positive 3 outside parentheses. I know that's a plus sign, but it also tells you that that 3 is positive. So when you're distributing that number, you're distributing a positive 3. Now what if that had been 1 minus 3? Then you would do negative 3 times 5, and negative 3 times negative 3x. Something else, probably the number one mistake that I see made on these problems. Let's go ahead and clear it up now, and so we'll never do it again. Can I go ahead and do 1 plus 3? Because it's right there together. Does it not look like you should be able to do 1 plus 3 if I covered this part up here? Doesn't it look like you should be able to do 1 plus 3? Here's what I want you to think of. And this is the reason you can't. What's being multiplied by 5 minus 3x? 3. That's all, right? Is the 1 being multiplied by 5 minus 3x? If I combine those and I made it a 4, and 4 was being multiplied by that, would that not mean that I kind of included this when it shouldn't have been included? Only 3 is being multiplied by this. I can't put these together because 1's not being multiplied times 5 minus 3x. So first step, you have to distribute. Go ahead and get rid of those parentheses first. Bring everything else straight down. Negative 28 plus 2x. 1. Carson, help me out. A positive 3 times 5. What is that?
15.
So plus 15. Now, why did I put a plus? Because it's not a negative. You have to put either a plus or a minus. Okay? So a positive 3 and a positive 5 would be a positive 15, and what was 3 minus 3x function?
Negative 5.
So minus 9. Yes, it is. Next step, move all your x's together, move all your numbers together. I have negative 9x. Let's move them all to the left side. X's go over here. Ethan, how am I going to move a negative 9x over here? Good. So plus 9x. Mark it out. Since I put my x's over here, which by the way is 11x, you can go ahead and put those together if you want to. Since I've moved all my x's over here, let's move all our numbers to this side. I'm going to put it under 15. It doesn't matter which one you write it under. So I have a plus 15. I have this plus 1 from here. And a minus 28 is going to turn into a plus 28. And I believe that's 44. We add those together. The last step is I need to get x by itself. In order to get x by itself, I've got to get rid of the 11. Zion, how am I going to do that? Well, they're being multiplied, so you're going to inverse operation instead of multiply. You're going to divide. Good job. So x must be, if you do 44 divided by 11, x is 4. Okay, this problem here is just in case you run up on something like this, what would you do? And I think I kind of covered it a while ago. I just want to make sure. Here you have 2 sets of parentheses. No big deal. Get rid of them. Using that same distributive property. If you have a negative outside, though, in order to get rid of a minus, you're distributing negative 1. You're multiplying everything by negative 1, but there's an easier way of thinking of that. Because look what happens. Negative 1 times 1 is negative 1. Negative 1 times 2n is a negative 2n. Anytime you have a minus out front, what can you just do to the stuff inside? 1 plus 2n turned into negative 1 minus 2n. So why not just change the signs? Right? A minus in front of parentheses simply changes the signs of everything inside parentheses. Equals 4 times 8 is 32. 4 times negative 2 is negative 8. Bring down the minus 3. The 4 is not being multiplied by negative 3. There's another mistake people make. The 4 is only being multiplied by the stuff inside parentheses. The minus 3 just gets brought down. And now let's talk about this as a group. Would you move? I don't want any negatives. I don't want to work with negatives. So should I move the negative 2n or should I move the negative 8n? The 8n. If you move the negative 2n by doing plus, you'll have negative 8 plus 2. And for those of you that still don't understand positives and negatives, in order to do negative 8 plus 2, negative 8 means that you're in debt $8. That's what negative is. Negative is debt. Positives is money. Okay. So negative 8 plus 2 is like being in debt $8, and you just found $2. Well, you're not in debt $8 anymore, but unfortunately you can't pay all that debt off. So negative 8 plus 2, you're in debt 8, but you found 2, so now you're only in debt 6. So that still would be a negative. So let's do it the other way. Instead of moving the negative 2 over here, let's take minus 8 and move it over here with this. I do it plus 8. Here's your equal sign. Let's move everything number-wise under the 32. We have 32. Here's minus 3 that did not move across the equal sign, but minus 1 did. A negative 2 and a positive 8. Now that's right the opposite. You have $8, but you owe $2. That's negatives, positives, owing money, having money. So a positive 8 and a negative 2 leaves you with a positive 6. You can add in any order you want to. I'm going to do 32 plus 1 and then minus 3, which gives me a total of 30. And if 6 ends is equal to 30, and from this step on, obviously it's common sense. It's going back to, you probably did these in about third grade. Except for it looked like this. 6 times, actually it's a big X, wasn't it? 6 times box equals 30. You solved equations back in third grade. That last step was the type of equations you solved back then. 6 times box equals 30, what goes in the box, right? That's what this is. 6 times box is equal to 30, what goes in the box? 5. Because to get rid of multiplication, you're going to divide on the other side, and you're going to get 5. Now something else, and I'll show you on this next problem. Honestly, you can save even more paper if you want to. We'll do this first one, and I'll show you what I mean by that. Especially for you inspired math competition, math team people, you don't even have to show me that much work, as long as you're getting problems right. Now, I want you to be confident that you're right before you're able to do this. First step, watch what I'm doing here. First step, distributive property, I have 35n plus 28. Now, this one might be hard to do on. Negative 8 times negative 5 is a positive 40. Negative 8 times negative 5 is also a positive 40 minus 2n. I'll put that equal sign in. If you can do this next step in your head, you don't even have to show me what you're adding and subtracting. I have 40 ends. Let's move all our ends to the right side. I have 40, right? But I've got to move these 35 over here. Anybody do 40 minus 35 in their head? 5. But you also have to combine this minus 2. What's 5 minus 2? If you can do all that in your head, you don't have to show me what you're moving. All I did was 40. I took away this 35, which left me with 5. And then I took away these 2, which left me with 3. On the left side, I have 28. I've got to take these 40 away. And you don't have to put minus 40. Okay? If you can do it in your head, if you can do 28 minus 40 in your head, or if you want to punch it straight into your calculator, you don't have to show me what you're adding and subtracting. Just do it. What is 28 take away 40? Negative 12. That makes sense. And the same way on this last step, you don't have to show me that you're dividing by 3. Just do it. What's negative 12 divided by 3? Negative 4. N is negative 4. So if you just want to do the steps instead of showing me the steps, I'm okay with this. Okay, here we go, next problem. Don't freak out when you see problems like this. There's absolutely no difference between this and what you just did. Except for you probably want to use a calculator. Step number 1, distributive property. I'll take my calculator out and get distributive property, so I've got 2, let me move that out of the way. Negative 24.91194 minus 0.1 R, which is something else. If you don't like the letter R and you want to use X, that's fine. Take out the R, put it in X. If you only use the letter A, if you like for some reason you have a preference for the letter A, take out the R, put it in A. It doesn't matter what letter you use. The reason I say that is sometimes some of my letters look like numbers, so I don't use them. I substitute something else in. So we've got to do distributive property negative 4.9 times both of these. So I have negative 4.9, and I'm not going to worry about my negatives. I know my rules for negatives and positives. I'm only concerned with what is 4.9 times 1.693. And I get 8.2957. So that is negative 8.2957. Everybody, R. Everybody good with that? Now I've got to do negative 4.9 times negative 2.9, which is a positive. I'm going to run out of it. 4.9 times 2.9. 14.21. And I've also got this minus 4.7 to bring down. So what I'm getting at here is, even when you're working numbers or problems with decimals, guess what? Real life has decimals. When you're working the problems that contain decimals, don't worry about it. You got calculators. They'll do decimals for you. Next step, now we've got to combine like terms. And that's the reason I showed you a while ago. Don't spend all your time writing all that down, what you're going to add, you can. But if you want to just type it straight into your calculator, that's fine. Like what? I've got, let's see, let's do our R's first. Do you want to move minus 0.1 R's, or do you want to move minus 8.2957 R's? Yeah, minus the 8.2, then you're going to end up with positive. So we're going to take this and move it over here. Since it's a minus, it'll turn into a plus. So you have, on your calculator, clear, negative, and of course you won't type it in the same on yours, negative 0.1 plus 8.2957. And I get 8.1957. That makes sense. Equals. So I've gotten rid of these. We're going to move anything that's not an R to the right side. You already have 14.21. You already have minus 4.7 over there. And I've got to move minus 24.91194. How do you move minus? Anybody? How do you move the minus? Turn it into a plus. Good. So plus 24. I don't have room. 24.91194. And I get 34.42194. This is taking a while. Last step. Hunter, what do I move next? Divide by that, right? In order to move 8.1957, since it's being multiplied, like you said, I'm going to take this and I'm going to divide by this. And it's still on my screen. Right there it is. So I'm going to do that number divided by 8.1957, and I get 4.2. And even though this contains lots of fractions, you still do the same 3 steps. That's what I'm trying to get across to you. The decimal problem we just worked, we did the same 3 steps. I got rid of parentheses. I moved on my like terms, x's to one side, numbers to the other side. And last step, I divided. You're going to do the same thing here. Except for here's going to be the issue. And here's your quick review on fractions. To multiply fractions, if you don't remember, you might want to write this down. If they're entirely fractions, excuse me, to multiply, guys, multiply tops, multiply bottom. Done. To divide, two-thirds divided by 4/5. To divide, does anybody remember how to divide? It's a lot like multiplying. Now, here's what a lot of people do. They'll try to divide 2 divided by 4 and 3 divided by 5, because that's what you do to multiply. What do you do with the second one? Flip it and multiply. 2/3 times 5/4. Now, how do you multiply? Same thing. Just did it. So really, division and multiplication is the same thing. Multiply tops, multiply bottoms, you get a 10 and a 12. But always remember, reduce if possible. For those of you that remember how to cross cancel, that would have also been possible. 2 and 4, you can reduce that before you multiply. So that's multiplying and dividing. Now here's the 2 that people have issues with, adding and subtracting. Before you can add, what has to be true? Bottoms, same. Before you can add or subtract two fractions, and they're the same, we'll just put add or subtract because you subtract the same way. Before you can add or subtract, you must have the same bottom. So we're going to have to try to figure out something that the 3 and 5 can turn into. Now let me explain what I mean by that. You can turn a 3 into a 6, 9, 12, 15, 18, 21, 24, 27 by multiplying. You can multiply this by 1, 2, 3, 4, 5, 6. You can multiply by anything you want to as long as you multiply the top by the same thing. So if you want to multiply top and bottom by 2, that'd turn into 4 and 6. That's fine. Same thing. Same thing over here, 4/5. If I want to multiply top and bottom by 3, that'd be a 12 and a 15. Okay? So the rule is to change fractions, multiply top and bottom by any number you want to. So now back to my first question. What can I change a 3 and 5 both into? 15. I can turn a 3 into a 15 by multiplying by 5. I can turn a 5 into a 15 by multiplying by 3. And that, and some teachers told you that in the past, that if you can't think of a common denominator, just multiply those two numbers together. So here's what I'm going to do. I'm multiplying top and bottom by 5. I'm multiplying top and bottom by 3. So now I can add it. 10 15ths, 12 15ths is 22 15ths. Which, by the way, is improper fractions. When you get to pre-calculus, you probably just leave it there. That's the nice thing. The harder the math you get into, you put it improper. But if you want to change that back, because there's only 15 15ths. A whole is 15 out of 15. Now you got 22 out of 15, so you've got more than a whole there. 15 will go into 22 one whole time. You've got one whole. Take away those 15. Or if you want to do it like this, 15 into 22 at one time with 7 left over. So 1 and 7 15ths. You can leave your answer either way. But all of that to do this. Now let's go back to our problem. Step number 1, get rid of parentheses. So we've got to multiply everything in parentheses by this. Everybody knows how to multiply, right? Multiply tops, multiply bottoms. So if you want to, you could do 33 over 6 and reduce it. That's one way of doing it. Or, instead of reducing it afterwards, let's reduce it before. It's called cross-canceling, but cross-canceling and reducing is the same thing. 11 thirds and 3 halves, neither one of those will reduce. But you can also reduce at diagonals. What about 3 over 3? Would that reduce? 1 and 1, won't it? So you could put a 1 there, put a 1 there. Multiply that together, you get a negative 11 halves. Multiply tops and bottoms here, 11 thirds and 9 fifths. Let's reduce before we multiply. 9 and 3 reduces. 9 over 3 reduces into 3 over 1. So that'd be a 33 fifths. Not equal. Minus 5 thirds equals x minus 63 fifths. So that's step number 1. So we're lucky. We've only got 3 steps and already finished number 1. Step number 2 is probably going to be your hardest one. Step number 2 is we have to combine all like terms. We have negative 11 halves x and we have x. So we've got to take negative 11 halves and let's move it over here to the other side and change it to positive 11 halves. Which, by the way, once again, that's 1x there. And while we're at it, let's go ahead and move this stuff to the other side. Negative 33 fifths combines with negative 5 thirds, combines with positive 63 fifths. I moved that, moved that. So now we're ready to go. First, let's add together 1 plus 11 halves. How in the world do you do 1 plus 11 halves? Well, what's close? You don't remember. That's 1 over 1. That's better. Make the bottoms the same. What can we turn both bottoms into? 2. How are we going to turn that into a 2? Multiply top and bottom by 2. So this is 2 over 2 plus 11 over 2. 2 out of 2 plus 11 out of 2 gives you a total of 13 out of 2. Everybody good with that side? I won't put that in the box because we got major over here. Now, look at these other. We got to add all three of these together. Now, a lot of you would stop right here and you're going to start finding common denominators down. You have three things to add together. Why not go ahead and add the stuff you can't add now? It might make your life a little bit easier. Can you go ahead and add negative 33 fifths and positive 63 fifths? If you can, somebody tell me what you get. 30 fifths. 30 over 5. Let's look at that. If you add negative 33 fifths plus 63 fifths, you get a total of 30 fifths. I need for you to do this. Understand that there is a close connection between fractions and division. When you're dealing with fraction, what does that bar mean? Does anybody know? Here's your hint. Where did the division symbol come from? How did they come up with a division symbol? You know what the division symbol is actually a picture of? A fraction. In the place of the numbers, they put dots. A division symbol is a fraction bar. Did you know that? Look at how this is a fraction bar. A number divided by a number. Okay? So a fraction and the division symbol are used back and forth. They're interchangeable. So 30 fifths is the same thing as 30 divided by 5. I want a different color. Come on. You know how to see that. So what is 30 divided by 5? Good. Didn't that make things a little bit easier? Because now we did negative 33 fifths plus 63 fifths and got 6. Now we got to do 6 and combine that with minus 5/3. That's 6 over 1, by the way. Much easier to find a common denominator there because before, some of you are looking ahead thinking, we're going to have to use 15 as a common denominator. We don't. 6 over 1 minus 5 over 3. Common denominator would be 3. Multiply top and bottom by 3. And again, you can do it in your head if you can, if possible. Multiply top and bottom by 3 gives you 18 over 3 minus 5 over 3, which is 13 over 3. So my problem now looks like this. And I'll scroll back up. Some of you didn't look at it yet. I have 13 over 3 on the left side equals 13 halves x. JC, help me out. I've got to get x by itself. 13 halves is being multiplied times x. Since those are being multiplied, JC, how can I move this 13 halves to the other side? Dividing it. There you go. And think about how we divide. And some of your algebra teachers told you to do this. They told you to just multiply by the reciprocal. That's why. Because in order to divide by 13 halves, well, think about how you divide. If we want to do 13 thirds divided by 13 halves, don't we flip and multiply? So why not save yourself a step? Instead of dividing by 13 halves, why not come over here and do times 2/13? To divide by 13 halves, you flip and you multiply by it. Now it's gone. The 13s cancel each other out, and you're left with x equals 2/3.